Rahman, check. Rahman, check. Confirm. Unmute and confirm.
Confirm, sir.
Okay. Rahman, voice.
Hello, sir.
Okay.
Yes, sir. Okay, sir.
Right.
Right.
Is our voice what?
Sorry, sir.
Is our voice what?
Yes, you are audible, sir.
Fine. Thank you.
Okay. Hello. 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 Am I audible? Hello.
Yes, medical.
Hello. Ara.
Hello. Hello.
Hello. Hello.
Morning all. Success is not the key to happiness. Happiness is the key to success. If you like what you're doing, you may be successful. A very good morning to everyone present here. I, Dr. Sumit Hangargi, Associate Professor in the Department of Mechanical Engineering. I take the privilege to warmly welcome to all the dignitaries on the first day of 1 week Emerging Trends in Faculty Development Program, Emerging Trends in Medical Additive Manufacturing, AI and ML Approaches, organized by the Department of Mechanical Engineering, Lord's Institute of Engineering and Technology. We are truly privileged to have with us today an esteemed gathering of dignitaries, respected academicians, resource persons from premier institutions, and enthusiastic participants from across the country. This FDP is a unique opportunity to explore how cutting-edge technologies like 3D printing, artificial intelligence, and machine learning are revolutionizing the medical field, from prosthetics and implants to personalized healthcare solutions. I extend my heartfelt gratitude to our management, our conveners, coordinators, and every contributor to who made this initiative possible. A special thanks to our chief guest, a guest of honor, and all the speakers for sharing the times and insights with us. Once again, I warmly welcome each one of you and wish you the insightful and inspiring week ahead. Thank you. Now I take the privilege to warmly welcome all our dignitaries onto the dais. I request Mr. Samantam Madhukar sir, Associate Head, Department of Mechanical Engineering, to please take the seat on the dais. I request all the students to please have a great applause for everybody. Now I request our head of the department, Mr. R. Suman sir, to please take his seat on the dais. Now I request Dean IQAC, Dr. Santan Kumar sir, to please take his seat on the dais. I request Dr. Nagi Reddy sir, Dean Academics of Lord's Institute of Engineering Technology, to please occupy his seat on the dais. I request Dr. Maksud Alam sir, Dean R&D, to occupy his seat on the dais. Now I request Vice Principal and COE, Dr. Azam Pasha sir, to please occupy his seat on the dais. A huge round of applause for everybody, please. I request a dynamic principal, Dr. R.K. Singh, to please occupy his seat on the dais. A huge round of applause. Welcome, sir. We welcome you for this 1 week FDP program. Now it's a time for us, and it will be a huge privilege for me to welcome our guest of honor for this FDP, Professor Dean CDC and Professor Department of Mechanical Engineering, Usmania University, Hyderabad. A huge round of applause, everybody, please. The clap should not stop for our guest today. Thank you, all the dignitaries. Thank you, everybody. To welcome is to honor, to welcome is to establish the integrity. I invite Samantha Madhukar, sir, Associate Head of the Mechanical Engineering Department, Lord's Institute of Engineering Technology, to deliver the welcome address.
Good morning, everyone. It is my distinct pleasure and honor to welcome you all to the inaugural session of our one-week national virtual development program on emerging trends in medical additive manufacturing, AI and ML approaches, organized by the Department of Mechanical Engineering, Lord's Institute of Engineering and Technology. This initiative stands as a testament to our commitment to academic excellence, innovation, and industry-aligned learning. We are proud to collaborate with IMechE and Professional Education Services in hosting this enriching FDP. At the outset, I extend my warm welcome to the esteemed dignitaries, Dr. R.K. Singh, patron of the FDP, Dr. Syed Pasha Qadri, Vice Principal and HOD, convener of the FDP. Sir, now it's my privilege to welcome Dr. Bakshi, sir, onto the stage, please.
We welcome Mr. Bakshi, sir, who is the Director of Entrepreneurship and Innovation of Lord's Institute of Engineering Technology. Welcome you, sir, for this FDP.
Yeah, okay, continuing my welcome address. Now, I also, Mr. C.A. Tanvir Ahmed, sir, Joint Secretary, Chief Patron. Sir,
Now I request, we welcome Dean First Year, Dean Evaluation and Planning, Dr. Shashi Kiran, sir, to this FDP. Welcome, sir.
okay, so, sorry for interruption. I will retake my welcome address. Good morning I welcome all the dignitaries. Good morning, everyone. It's my distinct pleasure and honor to welcome you all to the inaugural session of our one-week National Virtual Development Faculty Development Program on Emerging Trends in Medical Additive Manufacturing, AI and ML approaches, organized by the Department of Mechanical Engineering, Lord's Institute of Engineering and Technology. This initiative stands as a testament to our commitment to academic excellence, innovation, and industry-aligned learning. We are proud to collaborate with IMechE and Professional Education Services in hosting this enriching FDP. At the outset, I extend a warm welcome to esteemed dignitaries, Dr. Syed Pasha Qadri, Vice Principal and HOD, for Vice Principal, convener of the FDP, Dr. Anwar sir, Senior Professor and Director of Evaluation Advisor, who is not currently here, will be joining us. And also welcome Dr. R.K. Singh, Principal, Patron of the FDP. And also welcome Mr. R. Suman sir, HOD of the Mechanical. And also it's my pleasure to invite all management members like who are not available but virtually joined us. Mr. C.A. Tanvir Ahmed sir, Joint Secretary, Chief Patron for this event. And also Mr. Syed Tausif Ahmed sir, Vice Principal and Chief Patron for this. And also Mr. Ridwana Begum ma'am, Secretary and Chief Patron for this. And also Chairman sir, C.A. Basha Mohiddin sir, who is the patron for this. And also it's my pleasure inviting all the chief guests, Dr. Santan Kumar sir, Dean IQAC, Dr. Maksud Alam sir, Dean R&D, Dr. Nagir Reddy sir, Dean Academics, Dr. J. Shashikiran sir, Dean Planning and Evaluation. And it's my proud welcome to welcome Professor Rega Rayan sir, Dean CDC and Professor Mechanical Engineering Department, Usman University Guest of Honor. So we are deeply grateful for your presence and continued support, sir. The theme of this FDP reflects the dynamic convergence of mechanical innovation, healthcare solutions, and intelligent systems. Additive manufacturing, particularly in the medical domain, is rewriting the rules of design, diagnostics, and delivery. With the integration of AI and machine learning, we are no longer just building machines. We are building smarter, responsive, and adaptive medical technologies. Through this week, you will be engaged with some of the brightest minds from top universities, IITs, NITs, renowned industries, and also leading industries. The sessions will have been carefully curated to ensure a balance between theory, research, and practical exposure. On the behalf of the organizing team, I invite all the participants to make the most of this opportunity, ask questions, explore ideas, and engage deeply. Once again, I welcome all and look forward to an intellectually regarding week ahead. Thank you.
Thank you, Madhukar, sir. It was really insightful. As you know, this FDP is unique opportunity to explore how cutting-edge technologies like 3D printing, artificial intelligence, and machine learning are revolutionizing the medical field, from prosthetics and implants to personalized the healthcare solutions. Now, request our students to please give a plant chief guest, Dr. Professor, CDC and Professor. Please use. Please take. Thank you, sir. Now I request Singh, sir. I request all the students to please continue your class. Thank you, sir. Now I request a student. Question, sir. A huge round of applause. All the students are requested to please have a continuous claps for our faculties and the FDP guests. Now I request a student to please present. Singing, sir. I request to please present. Sir. A clap should never stop the program. The clap should continue for our faculty, for our deans, and for our HODs. I request to present the plant, the Dean IQAC, Dr. Santan Kumar, sir. Thank you, sir. Now I request to present the first year and Dean evaluation and training, Shashi Kiran, sir. A huge. Thank you, sir. Thank you. Sir will be always for us to support for our department, for our faculties. Thank you, sir. Now I request to present sir. A huge round of applause. Thank you, all the dignitaries. Now I request to please leadership in innovation, Mr. Bakshi, sir. A huge round of applause. Now it's a time for all our dignitaries to please speak few words on this faculty development program. I request Mr. R. Suman, sir. A huge round of applause. Our Joint Secretary, Mr. Tanveer, sir. The 1 week faculty development program. Thanks for coming, sir. I request a student to please give a plan. Mr. Tanveer, sir. A huge round of applause. Sir. Thank you, sir. Now I request Mr. R. Suman, sir, Head of the Mechanical Engineering, to please speak few words on this occasion.
Very good morning. Respected Tanveer sir, Principal Dr. Ravi Kishore Singh sir, Vice Principal Dr. Syed Azam Pasha Qadri sir, Dean Academics Dr. Nagir sir, Dr. Santan sir, Dr. Shashi Kiran sir, Dean R&D, Dean P, my faculty members, and chief guest, and speaker, the Professor Rega Rajendra sir. Very good morning to each and every one of you. Sir, the Department of Mechanical Engineering aggregated 3 times MBA, and the Department of Mechanical Engineering is having 3 patent grants. Recently, we have got one more patent grant. Well-equipped laboratories, well-experienced faculty members. And here I have to mention very important note about Professor sir. Recently, there was a service with particular, especially on learning outcomes. On this note, Sarah suggested it's better to have faculty program to enrich the faculty knowledge, because it is a continuous learning process. And by the suggestion by this initiation, we requested management and the principal sir, we are planning a faculty development program, and that it is a national level and virtual mode. Then very instantly they agreed. And our Mr. Madhukar sir, he had a discussion with Rega Rajendra sir. And then finally, the committee has decided emerging trends in medical additive manufacturing with AI and ML approaches. So here you can see that one is additive manufacturing, one is medical field, and the very important is AI ML also. By keeping this title, the very next, we decided to choose the right speakers. But very first, Professor, after giving a call, sir has agreed on the request, and today sir is having a first talk on this FDP. Sir, thank you very much, sir, on behalf of Department of Mechanical Engineering and Lord Institute of Engineering and Technology. Even sir is having very busy schedule, but the dedication you can see here at this level, the science and supporting the campus like Lord Institute of Engineering and Technology, and you all family member of Usmania University, right? So we need continuous support from you, sir. Sir, here, both international speaker, and one is from NIT, and the speaker, industry, sir, and one speaker, Mr. Nikhil, Professor Nikhil from EC department, sir. So it is a faculty development program. So I request all the participants need to maintain concentrate, the speakers are presenting their valuable skills towards faculty, knowledge, and helping the student community also. So, especially thanks to Professor head of the Department of Mechanical Engineering. Sir has given his valuable time, will be attending on 26th. And apart from this, sir, we are doing this everything in collaboration with IMechE. So IMechE student chapter professional education services. So mechanical engineering, I definitely, and we thanks to our management for accepting this, and especially Tanvir sir, thank you very much, sir, for accepting for the session. With this, thank you each and every one of you for showing your interest and make this event a grand success. By 26, this event will be completed. Make sure you will be carrying the quality of information, and definitely will feel that by end of the day, you will realize how much the professors, the different speakers got involved into this faculty development program. We assure you, definitely there will be a good outcome from this faculty development programs. So with this, thank you each and every one of you. And once again, thank you, Professor Rega Rajendra sir. Thank you so much.
Thank you, sir. Thank you for your insightful talk. Now I request Dr. Santan Kumar, sir, Dean IQSU, to please speak few words on this occasion.
Very good morning to the dignitaries on and off the dais, especially our family member, Professor Rega Rajendra sir. He is our GB member. His valuable guidance and valuable suggestion in the last GB meeting oriented our direction towards getting better results of this institute. Thank you, sir. And our management always believe faculty as backbone of the institute. Conducting faculty development programs certainly help to transfer that knowledge to students who are our primary stakeholders. Not only mechanical department, every department, they are focusing in upskilling the faculty. They are focusing
Thank you, sir. Thank you for congratulating the team and all faculties of the Mechanical Engineering Department. Now I request Dr. Nagireddy, sir, Dean Academics, to please speak few words on this occasion.
Chief guest for today's FDP, Dr. Rega Rajendra sir, Professor of Mechanical Engineering and Dean CDC, and also the governing body member to LIET and our advisor. Respected Joint Secretary sir, CA Syed Tanvir sir, Respected Principal Sir, Dr. R.K. Singh Sir, co-fellow Deans, Head of Mechanical Engineering, Suman Sir, our Advisor for Entrepreneurship, Udayan Bakshi Sir, in first year, and the Coordinator, Madhukar Sir, and the participants. Good morning, one and all. So first, let me congratulate the mighty Mechanical Department for organizing these kind of effective quality FDPs. So I think this is the third event that is inaugurated in the same seminar hall in association with IMechE department, IMechE student chapter. Okay. So I congratulate the student chapter of Mechanical Engineering department also for effectively conducting these workshops. And just now Suman sir told that 3 patents are already granted to mechanical department. That is, I think, that is the highest in LIETs. So much of research is happening. Even I personally visited the mechanical engineering laboratories where the e-vehicle is underway, right? So I think very soon that will be out with so many latest features. Even in terms of other publications also, so mechanical engineering is in the top position. Previously, the research was limited to a particular domain. So mechanical people were doing the research in mechanical domain, CSE people were doing the research in the CSE domain. So now it is the era of the multidisciplinary research, where all the departments coming together and doing the research. So by looking at the title of the FDP, Emerging Trends in Medical Additive Manufacturing in AML Approaches, right? So already mechanical engineering doing wonders in 3D printing. Even I think our faculty members went outside and conducted so many seminars and guest lectures on 3D printing, right? So 3D printing helps the medical industry in a lot of way. Now coming to A&ML, so far, if a patient goes to a hospital, after diagnosing a particular disease, then only the treatment begins. Now with the use of this A&ML will analyze the data given. Definitely we can predict the disease. We can predict the disease and avoid the disease also. So this is a wonderful FDP that is chosen by our mechanical engineering department. So I once again congratulate the mechanical engineering department. I advise. So by recognizing the importance of this FDP, even 5 faculty members from IT are participating in this FDP. So I advise all the faculty members to utilize this opportunity and extract the maximum benefit with this FDP. So once again, congratulations to Mechanical Engineering Department and thank you for inviting me here.
Thank you, sir. Thank you for your talk on this faculty development program. Now, I request Mr. Bakshi, sir, the Director of Entrepreneurship and Innovation, to please speak few words on this 1-week faculty development program.
Thank you so much. The chief guest, all the dignitaries on the stage, participants, my dear students. How many of you understand this topic? Please raise your hand from these participants and students. Because I'll be asking you questions. So before you raise your hand, think, how many of you understand this topic? But I want you to understand one thing. If you see the trend at the developed countries, US has closed the outsourcing jobs as high as maybe 40-45%. They are going into manufacturing. Germany, France, and like that, all other countries, they are focusing on manufacturing. Any idea why those countries are focusing and converting their power into manufacturing, going back, backward integration? Why? Why it is so? Why China is the world leader? Why China is the world leader? You got the point. So you're sitting at the right time, at the right place, with the right people on the dais, right? And if you cannot take the advantage of this golden opportunity, ask them with thousands of questions, be behind them, say, sir, I need this project, I want to work in this. By the end of this FDP, If you cannot back individual projects from the dignitaries on the stage, I think that's a waste then, right? Work with them, explore, because this is the future. And that is what I can say. Thank you all. Thank you.
Thank you, sir. Thank you for giving to the students to present FDP and you said about the importance of manufacturing also. Thank you, sir. Thanks for the thanks for your talk. Now I request Dr. J. Shashikiran, sir, to please speak few words on this occasion.
Respected Professor Rega Rajendra sir, Dean College Development Council, Usmania University, respected Principal sir, respected management member, our Joint Secretary Tanveer sir, other deans, colleague friends, faculties and student friends. First of all, thank you to our beloved Chairman sir for not closing mechanical department and giving a chance for us for conducting such type of events in emerging era, all CSC allied branches. For our chairman sir, given an opportunity for us to develop our community, to develop our student community towards the mechanical and civil and electronics era also. For that, we always thanks to the management. Thank you, sir. Whereas all other colleges merging mechanical, civil, electronics and electrical and taking opportunity to give more about CSC and allied branches. But our management take an initiative, not close mechanical and other branches. For that, I would like to extend my warm thanks on behalf of student community and faculty community for our management. Secondly, as Bakshi and other deans mentioned, please utilize the opportunity in online who are the faculties attending, requesting you all, ask you all the mechanical department faculties to attend this 1 week FDP. This is our humble request on behalf of our mechanical engineering department from Lord's Institute of Engineering Technology. HODs, deans, principals of all other colleges, please encourage your staff to enhance their knowledge through this FDP so that the Department of Mechanical Engineering will develop and automatically the Hyderabad will develop, automatically state will develop, automatically country and global will develop. Thank you very much for inviting me. Thank you.
Thank you, sir. Now I request our Vice Principal and COE, Dr. Syed Azam Pasha, sir, to please address the gathering.
Good morning to one and all. Respected dignitaries on the dais, off the dais, respected guest of honor, Professor Rega Rajendra sir, and management member, Joint Secretary Tanveer sir, and my dear faculties and all participants. A very good morning. First of all, I thanks for conducting this 1 week virtual national level faculty development program on emerging trends in medical additive manufacturing and ML approaches. As the title indicate, this FDP is surely going to be very grateful to all the faculties, especially to bridge the gap between the industries, medical field to the engineering. This field is an emerging and redefining the transforming of the medical issues. When we talk to the medical officers, they express their CT scan, MRI, very complicated. When we printed that in 3D printing, by seeing that component, they have easily analyzed what are the fault in that, and before going to the operation room, they have inspected and they have identified the fault, which is very complicated to get the correct picture of the in MRI and CT scanning. That can be done with the help of the AI, ML with 3D printing. Make sure that this is the emerging trend, and to take the healthcare is very necessary, and this is the futuristic development. So we initiate this FDP program with very good speaker across the country and international also. So I request all the participants be active for this 1 week and take this opportunity and try to learn how to explore in 3D as well as in the medical field. So in this conclusion, I can say that this is the redefining the medical transformation. In this connection, I again thanks to our Dr. Mr. Sumas and organizing chair, Mr. Madhukar, has taken a great make this event successful, and I felt very thankful to our beloved management, Chairman Sir, CA Basha Mohyuddin Sir, Joint Secretary Sir, Tanveer Sir, Vice Chairman Sir, Tausif Ahmed Sir, and our Secretary Madam, Rizwana Madam, for giving this opportunity to conduct this FDP program. Once again, I thanks to all the management, and I request all the participants be active, whatever the doubts, especially in 3D printing, in collaborating with AI and machine learning with the medical field, which is very important and very essential, and this is the futuristic technology. Make sure that utilize this session effectively. Thank you. Thank a lot.
Thank you, sir. Now I request our principal, Dr. R.K. Singh, sir, to please address the gathering.
Morning, everybody. Dr. Rega Rajendra, sir, OU CDC, Dean CDC, is here with us. Joint Secretary, sir, Tanveer, sir, is there. My other deans and vice principal deans and senior faculty members, the audience here and the faculty of mechanical, I welcome you all to this faculty development program. Long back in 90s, fuzzy logic and neural network was the talked about thing. And when I asked my professors, what is the final aim you want to achieve with fuzzy logic and neural network? He said, the days are not far when a paralytic patient, a patient who is having paralysis of, say, hand, legs, or anything, will be able to move. He'll be able to do his basic daily routine himself. So with that aim, this entire technology started. Machine learning in form of, identification of good components from bad components on a layer of machine, which is on the layer which is moving, to isolate the defective component, was very famous in mechanical engineering most of the industries where, defective component used to be picked up by an arm and kept aside, and only the objects following quality control could follow through. Today, the technology has come very, very, very far. Neural network has become a part of deep learning, which is a part of AI, and AI has taken over everything. And I'm very sure that one thing which we wanted to achieve, that is to make a paralytic patient, a patient under paralysis, to move his arms and legs, that would be done very, very soon with the technology which is now coming up. You are lucky that we are in this generation where all this thing is happening, new and new technology is coming up. And a word before I hand over the mic to the compare, a word about mechanical engineering department. Just yesterday or day before, my HOD told me all his final year students are placed. Let's have a clap for our mechanical engineering department. All the final year students have been placed. I can't say that about my other departments, like computer science, data sciences, machine learning, even IT, not all are placed. And we were talking about, Vice Principal was talking about not closing the mechanical. Definitely it cannot close. It is the backbone of engineering, mechanical. In every field of design, in every field of construction, and they're going to go stronger and stronger. Thank you very much for calling me here and making me part of this beautiful journey of, emergent trend in medical additive manufacturing. Additive manufacturing is already there in our college. It's part of the excellence centers. And now we want to do a lot of things in the medical field of additive manufacturing. And this is what is the thought process of our FDP and also the college. Thank you so much.
Thank you, sir. Thank you for your talk. Now I request our Joint Secretary, Mr. Tanveer, sir, to please address the gathering.
Good morning, everyone. Good morning to respected guests today. Good morning to, and I thank you, Rega and Professor Rega Janazendra, sir, who has spared his time to come and attend this FDP and address all the other faculties and all the viewers and listeners. Professor Rega Rajendra, sir, is also a governing body member who is deeply concerned with the institution's performance. He's a well-wisher and he has always shed us light on many aspects which were overlooked by others. So this is the level of effort put by Rega Rajendra sir to our college. Please give a round of applause to Rega Rajendra sir. I also thank you. I also thank the respected speakers who have spared their time and who are going to address in this 1 week national level FDP. They have the vision of whatever they have learned. They have the vision of teaching the same to the other people in the mechanical department. Similarly, I also congratulate the entire mechanical department for hosting this FDP. This topic on which the FDP is going to happen is a very unique topic, such as it covers multidisciplinary aspects, such as right now with the use of AI, the medical needs are also being met. This is a multidisciplinary project through which the knowledge of the 3D printing is used for the medical additives. Here, they will also be aiming for the sustainable development goals. It is very important for every professional, let it be a doctor, or let it be a lawyer, or let it be an engineer, or a chartered accountant, or some other professionals to be up to date with the trending skills. This is the very latest domain, and every professional should realize, apart from the teachers and every professional such as students who are going to be professionals later on, should also realize the importance of this and always aim to upskill themselves. Students here who are from first year can also learn all these topics and have projects, make projects on these domains. AI, there's a very famous quote these days that AI is the last invention that humanity will ever make. Because after AI has been made, most of the inventions will be made by AI itself. So it's very important for everyone to be aware of the artificial intelligence and also upskill yourselves in the upcoming domains. I wish you all the best, and I thank everyone, every speaker, and I wish you all get the maximum learning from this FDP. Thank you.
Thank you, sir. Thank you very much. We must be very thankful to the General Secretary, despite of his busy schedule, he found a time to grace this occasion. That's so generous of you, sir. It also shows how compassionate you are towards this FDPs and indeed, and college fraternity. Thank you, sir. Thank you once again. Now I request our guest of honor, Professor CDC and Professor, Department of Mechanical Engineering, Usman University, to please address the gathering. A huge round of applause, sir.
Very good morning. First, I'd like to congratulate the organizers of the Institute of Engineering and Technology, and supported by the management, Mr. Stanveer, and the department, college administration. We have Madhukar and Dr. Suman, Mr. Sumit, Anwar Ullah, and Santan Kumar, Nagareddy, Shashikiran, and Syed Azam Pasha, Principal, Dr. R.K. Singh, and Chief Patron, CA Syed Anwar Taimat, Secretary, then Secretary, College, Rizwana Begum, and Asif Antemani. So we have I due respects to all the persons and also dear students. Welcome to this program. So now the education mode is continuous learning. Okay, lifelong learning. Earlier, it was classroom-based learning. Education is not limited here, what you learn. Per semester, 180 days. So it is a continuous learning, and you need to learn every day, every hour, and update your knowledge. So because of the internet technology, that learn anywhere, anytime, any place, at your comfort. So that was the Government of India initiative to students to learn from anywhere, anytime. So that is online. Okay, online resources are available to you, and your time is very precious. So anytime you want, you can learn. Then that is the one-side learning. So after time, you have on offline learning here, classroom, face to face. So in this, when you come face to face, so you should have some vision, some mission to learn and get your doubts clear, get your doubt clear. Okay, and consult with the teacher or guru and clear your doubts, because in the online learning you may not clear your doubts. Okay, so that is the purpose of this online, offline. So what we see is online, 100 participants are there, and they can ask online doubts also. But you are offline, you can ask your doubt from here, and we can clarify here itself, so that your face-to-face interaction is there. And what you need is upskill, reskill, and continuous learning. So there is no stop for learning, no stop for innovation, because time is changing, environment is changing, technology is changing, and people are changing. So many things are happening simultaneously in many sectors. Okay, from social, political, economics, and cultural. So much of change is going on. So that you need to understand. So you are fortunate that you are attending a offline class like this. In future, we may not have so many, like, so in a limited class, we have 60, but offline, there will be 6,000 or one class. Okay, it can be 60,000 also online. So, and you need to, people who evaluate and give the marks are also subject experts. Okay, so that you have to think. And grading and evaluation is on the same scale as the national level, like CGPA you are having now. So it will be on the same par, the levels and the criteria of evaluation will be in the same level. So that you have to understand. Now coming to this workshop, the organizers have thought 3D printing. 3D printing, one of our speaker has mentioned that China is number one. If you go to any market, you have products made in China, products made in Germany, Switzerland. So high-end technologies. So that you can substitute here itself. And that solution is 3D printing. Additive manufacturing is your fancy. You can say your fancy. So once you know to product your design, you can make anything what your mind thinks. You can make it in reality. Earlier it was not possible. Just you have a vision, you have a fancy, I want this. So your product or component will be ready. You can have total printing of the machine, 3D printing machine. Okay, 3D printed machine, the mechanism, understanding. So that much of advantage this 3D printing is having. Okay, and coming to the critical sector, 3D printing to medical field. So already research is going in the development of 3D printing of bones. Okay, your skeletal structure, your head and all your palms. Just like if you fracture your any body part, you can print biodegradable material. You can print your bone. Okay, because you can scan and get the 3D geometry of the bone and again fit into your thing. So there will be in future, there will be what you call bone replacement also. So now, old age people are having bone density less and bone wear, and they are not able to walk due to heavy weight or some other reason. So that is one thing. Already, that not you, and the market is for human body parts, especially started with bones, biodegradable and sustainable bone structures. Okay, so that you already is going. Another thing is 3D printing of muscles. 3D printing of muscles for old dystrophic patients. So 3D printing of muscles using AI and ML. So what you see here, additive manufacturing combined with AI and ML. So design and logic, okay, and intelligent machine algorithms. So you can print your wish. You can say your wish. So that way it is. And in this case, as your mechanical engineering, you are strong in AM, additive manufacturing. But what AI and ML calls for is also you should develop skills in programming. So you should not let the computer deviate from this thing. If you learn programming, you become expert in this. Okay, and you become consultant. So tomorrow now you are having diagnostic centers everywhere. So any small disease diagnostic center is there, or any fault or any mishap, to evaluate your body skeleton and also the your body damaged part, muscle break or something like that. So in future, they'll be having machines to evaluate your body structures. So since it's a current coming technology, so you have to what you call learn. If you learn also no problem, and then you relearn it. Okay, advance. Then continuous learning. You're continuously learning. So you have 100 participants offline. What is their curiosity? Curiosity is they want to learn. What's he trying to tell? New thing. What new thing is going to tell? Some expert. Okay. So they are curious and they want to learn. Other thing is they are maybe interested in certificate also. So certificate also, I talked to the principal that give a certified certificate so that students will participants will benefit from that. Okay, so that is the thing of today. And in this direction, Madhukar and his team and mechanical engineering department has taken up this 3D printing additive manufacturing technology. This is technology of the future. Okay, the space components also you can manufacture. Space component, rocket science. Now more number of drones, flying objects, and you have flying taxis. You are going to have very near future. Here, Chennai, they already started a service because of so much congestion. Flying taxis, they are going to come, and all 3D printed, certified flying taxis. What you have autos now, Olo has come, no Olo ride and all those things have come. So in future there will be that, and not only that, it's a must display that civil engineering also 3D printing houses. 3D printing houses, template-based manufacturing. You have a template, simply put them just like assemble like a puzzle. Okay, assemble like a puzzle and assemble and your house is ready. but the house is taking, 6 months, something like that. So your house will be completed in, just 30 days or 20 days like that. Your house will be ready. And your designer house. Now interior design is taking place, no? Designer. As your fancy, earlier this fancy type of things were not there. Your visions, and this is because of computers programming, and computer are generating parts and components for customer use. So what customer wants, you are ready to print. Okay, now in all diagnostic centers, now that dentist is there. If your tooth is broken, whatever tooth, they take a sample copy, scan it, and they print and give you. Tomorrow you'll have 3D printings in all hospitals. Okay, 3D printing machines in hospital. They scan your bone, where it is fractured, and then print your bone. And when your bone is ready, they will call and fit into your body part. Just like if you damage your car, you go to garage. Just like you damage your body, you go to the hospital and refit a new material and come. So this topic is very apt, suitable, and futuristic too. So what does it mean? It means that you catch this 3D printing, practice it, do projects, publish papers, understand the processes, develop new processes, sustainable engineering process, green engineering you develop, and do innovation, patents. You try to create patents, then you make money and you be successful. So the message, you have to take, you are spending so much time here, you have to take some message, and the message is technology of future. You take this, use it. It's not like, throw away. You cannot neglect it. You cannot avoid it. Okay? You cannot avoid it. You think you can avoid it. So it's not my type of thing. No. Just like you're not able to avoid computer, you cannot avoid this also. Even your, now cyber security has come. You should know minimum things of operating a computer, minimum things of operating your cell phone. So, and not like the persons who born in 70s and all those things. Okay? So it is a non-avoidable technology. You cannot avoid it. Okay? You have to practice. Once you get into the flow, then you get some ideas, right? So with this, I thank the organizing committee and the college management for proposing this workshop and being part of this. I am being part of this workshop. So I am very grateful for inviting me, Madhukar and his team, and Mechanical Engineering Department, Principal, Vice Principal, and secretaries, and all other staff members. Thank you for joining this taking. Thank you. Welcome.
Thank you, Chief Guest, for today's first day virtual national level faculty development program. Now I request Dr. Asif Katumani, Associate Professor in the Department of Mechanical Engineering, to deliver the thanks and express our gratitude.
Thank you, sir. Yeah. Thank you very much. As we conclude the inaugural section of 1 week FDP on emerging trends in medical additive manufacturing, AI and ML approach, it is my honor and privilege to deliver vote of thanks on behalf of the organizing committee. First, I would like now to take a special moment to acknowledge and thanks our guest of honor, Professor Rega Rajendra Garu, Dean, CDC, and Professor, Mechanical Department, Osmania University. Your words this morning added depth, context, and the motivation to this platform, and we are truly grateful to have had your insight guides to beginning of this academic journey, sir. Thank you. Thank you very much. Next. Yeah, I extend our deepest gratitude to the pillar of support behind this event, our chief patron, Mr. C.A. Tanveer Ahmed, Joint Secretary, LIT. And yeah, obviously, respected our Syed Tanveer Ahmed, sir, Syed Tausif Ahmed, sir, Vice Chairman, LIT, and Mrs. Rizwana Begum, Secretary, Lords Institute of Engineering and Technology for their support. Your on your behalf, the academic honors in future focus to the program has always inspired us in pushing boundaries and the exploring new dimension. We sincerely thank our convener, Dr. Syed Azam Pasha Qadri, Vice Principal, for being the driving force behind this FDP. Your clarity of vision and academic foresight have made this program possible. Thank you, sir. Our yes. Next, our heartfelt appreciation to goes to Mr. Ramao Suman, sir, Head of the Department, and Mr. Madhukar, sir, Organizing Chair, the Associate Head who coordinates the commitment and planning have made this launch launch seamlessly. Thank you, sir. And I also thanks our esteemed deans who have joined this today, Dr. Santan Kumar, Dean Accuracy, Dr. Nagireddy, Dean Academics, sir, and Dr. Shashi Kiran, sir, from Dean Planning and Coordination. Your support and the encouragement reinforce the importance of the interdisciplinary growth and continuous faculty development. I would like to thank our organizing committee, the coordinator, co-convener, and the technical team for their tireless work behind the scene. Your efforts are what make the front stage shine. Next, with that, I conclude the vote of thanks. My this FDP spark new ideas, inspired collaboration and contribution meaningful to the future of medical and mechanical innovation. Thank you one and all the participants present here and online virtual. Now, I request our dignitaries to please ahead of the chair, please take the front chairs. And today's session, next I'll going to hand over our today's, yes, thank you, sir.
Thank you, sir. Thank you, Dr. Asif Katimani. I once again extend my heartfelt gratitude to our management, our conveners, coordinators, and every contributor who made this initiative possible. A special thanks to our chief guest of honor, and all the speakers for sharing the time and insight with us. Now we have a 10 minutes of break. So we have before starting the lecture by the chief of guest. Please have a break for 10 minutes and be back into the seminar again. Thank you all. I request students to please as chief is from Osmania University, he is specially for you only. So if you want to go for washroom, please go and come, but do not go. Everybody, be back to the hall within 10 minutes. So please, within 10 minutes, everybody. All the students, please come forward. Let us fill the front tables first. Come forward. Backside student, please come forward. Please come forward. Slowly, slowly. Nothing, sir. Off your mobiles, everybody. Off your mobiles and come forward. Take your seat, everybody. Sit.
Yes. Cursor move. Cursor move. Back. Wait.
Rahman, is this
Sir, bol.
Rahman confirm?
Yes, sir.
Rahman,
Sir.
Rahman.
Yes, sir.
Rahman, confirm?
Yes, sir.
Rahman.
Confirm.
Yes, Madhukar sir, your voice is audible.
Yes, sir.
माइक ऑन करो उसका पीपीटी करो पीपीटी फुल स्क्रीन कर दो
स्क्रीन पे भी आ रहा.
रायमन रायमन फुल स्लाइड इज विजिबल रायमन इज स्लाइड विजिबल
Please share the slide. Please go to the slide sharing option. Please share the slide.
Share, sir. Share it. Share. Share. You already shared. Raymond.
Yes, sir, we got it.
Huh? Yes, Dr. Smith.
Good morning, all. A warm welcome again to all the participants in this one-week virtual faculty development program on medical additive manufacturing, AI and ML approaches. Today we have a chief guest, a Professor Rajav Raghendra sir. He's a professor in the Mechanical Engineering Department at the University College of Engineering, Osmania University, Hyderabad. If we talk about his area of expertise, he received his PhD from IIT Kharagpur. He has a research profile on ResearchGate and Google Scholar. He was also awarded by the IIT Kharagpur under the QIP scheme funded by AICT and sponsored by Osmania University. His research focuses on experimental and additive simulation of mechanical properties of AI SI 10 mg parts manufactured by selective laser melting process. He has served as a faculty for mechanical engineering, that is also in production engineering specialization at. He has several publications, including the CV. So we welcome a chief guest, Professor Raja Raghendra sir, on the first day of virtual national level faculty development program on additive, medical additive manufacturing, AI and ML approaches. The session is all yours, sir.
Thank you.
Huge round of applause for our chief guest today.
Yeah, a very good morning to offline and online viewers and attendees. Very good morning. So my topic is successful 3D printing of AM components using laser powder bed fusion process. So this topic actually we did one of our students did PhD in this workshop. So actually this is implemented by GE, General Electric, for manufacturing of aerospace components. Powders are manufactured and supplied in the market. They do not give the specifications. So we want to make a 100% density component without any defects, fine defect, line defect, and also for high strength. That was our objective. So we did the first project, and we did on 250 model of the AM machine. So this machine is there in Wipro 3D also, and newcomers are also using it. So how do we proceed? How did we proceed to get a defect-free component? So that part I will tell, and test the component for structural strength and wear resistance. So these are mechanical properties. So that part we have. Any problem will be new. Any engineering problem will be new. First you have to write down what is your objective. Then for that you need to do some background study. Just simply you cannot start. Okay, you want to generate a skull of a body of a person or human being. So first you need to study the male or female. Then you need to study underage, middle age, old age. So like that, different categories. And you'd have to study systematically. Okay, so that's the topic. And we have generated this component and and put in National Archives of the PhD thesis. I think Sodan. So UGC portal. All PhDs will be put in PhD UGC portal. Successful, high rating, high technology research. They will be put in there. So you can also see them. So first is laser selective melting, and we did. Can I go there? Can I go there? Yeah. So we need to conduct. These are our properties, and we have to see gaps in literature, our problem statement, objectives of the work. In your project also, you need to do that. Then we have to design a workflow chart. Okay. Then once a component is printed, and you have to do the printing component, right? Then you have to conduct all these tests. First powder characterization. So many powders are there: steel powders, copper powders, then alloy powders. Okay, So titanium powders. So with this, you get geometric test, metallurgical test, experimental, mechanical, and NDT. NDT test you have to conduct. Okay, there should not be any porous. You can design as a porous also, lattice structures. But in this case, we want to have full density component, without any defects. Then you have to, once the material is ready, all these 4, 5 parameters, then you have to conduct this fatigue performance. Finally, the component is put to performance. Okay, just like your GRE, whatever you studied, GATE, CAT. Okay, so that you need fatigue performance of 3D printed component, and what was the variation you got. So this is as printed. But if you the component is working in real time, due to friction and friction generated heat and environmental heat also effect on the component. Okay, AM part. This AM part. So that will cause component failure. So for this also you have to conduct this in heated environment, heat treated cycle you have to conduct. Okay. So after that we did this. You now, since you have computer aided manufacturing, you can do AM part simulation. So this we did by educational version Hexagon 3D printed software. 3D printed software also we have. So this you can do the simulation, and printing and preheated with the FES simulation. So computer integrated analysis. Then you do physical testing of hardness and density part. Then microstructure evaluation, metallurgical as printed and preheated condition. So both you have to do this one. Then fatigue performance, number of elements, then wear characterization, as printed and preheated condition. Both you have to do this part. Okay. Then different environmental conditions, wear characterization and its methods of. So AM part, I did characterization using Taguchi L9 orthogonal array evaluation method, achieves optimal parameter setting. Okay, and 3D printed, preheated, age tempering, and also you see this one, cryogenic conditions. Okay, this cryogenic conditions, sometimes our component is also put in below 0 degrees centigrade. So we operate on -10, -15, -30. Okay, so that will be how the component performs. So cryogenic also we attempted, and as printed is what we have, preheated, and also long duration operation. This long duration aging, and this differently cryogenic temperature. The studies are conducted. Then this topology optimization, a case study for aerospace component, we have taken one. And this topology optimization did by simulation. So software is there. So what different geometric suitability for a given part. So that also is taken care of. All geometries are not suitable. For bone, different person has different geometries. Okay, and leg bone structure, femur bone structure, hand bone structure, and hand. So this will be skull. Skull also have a different this thing. So that we can do this simulation and arrive at a correct topology. Suppose a person is injured, his skull is damaged. So we need to find the correct shape, size, and also alignment between the main part and fractured part. So you have to align them both. Okay. So this topology optimization is used. Since aerospace component, you need light structures. Flying objects have to have less weight and more strength. So we try to study this lattice structure geometries, different geometries. In this case, only few simple geometries have been evaluated. Okay, and out of this, these are the publications. So what knowledge is for sharing. Okay, knowledge sharing should be there, and expansion of knowledge. Okay, like you have Google. Because of knowledge sharing, Google has become famous. Like Microsoft, they give some licensed software and some educational software and some free softwares. So like that, they have become free. Now everything is not for commercial. So this publication is knowledge sharing for others to implement. Okay, implement and practice. So that's the thing. So abstract is what is the methodology followed. So here, after a lot of abstract is what you call the whole thing given in small capsule. If you read the abstract, then you understand the whole philosophy of that work. Okay, the gist of the work. So finally, optimal process parameters for highest values of fatigue strength, density, hardness, with laser power of 225 watts, scan speed of 500, hatching distance 100 microns. Experiment results achieved high density of 99.6%. That is 2.6 grams per centimeter with the defect-free component. And hardness variation is 126 plus or minus 5 hardness value. Okay. So this is the output. So all those things with the heated condition, non-heated condition, and these things are presented in this abstract. So as I told, then how to do this one? How to do this topic? Find out the parameters. So you have to type these keywords. These keywords are very, very important. Here I am taking ALSI 10mg, thermal analysis, tensile properties, fatigue performance, characterization for ALSI 10mg. If you type these keywords, you get the information relating to ALSI 10mg alloy powders. Okay, so anything just like you are giving keyword. So from the keyword you get whole data from the net, right? So where it is applied. So this is all 3D printing, the process defect free. Challenging is the strength. Conventional material strength as manufactured. You have a 3D printing structure like this, and defect free, fully dense. That is the making real time a study component. So here, what are the benefits of AM? Benefits of AM is time for manufacturing. Very less time. You can design customized geometric shape and size. Customized, okay. Different persons have different requirements. So customized geometric shape and size. Then this time and this cost is now, earlier cost was high, now it's going to decrease because of multiple service providers all over the world. Just like you have internet caves, you're going to have 3D printing centers. Okay, already it is there. This is a new marketing strategy to produce your components, produce your metallic and non-metallic components. And this is very important thing. Innovation of new things, new ideas. Okay. New market creation. So innovation is the hallmark of 3D printing. Innovation will be 3D printing market. So why? Because I'm telling, in a class, all 60% are not same. There will be average, below average, and high. So, but all are unique. All are unique. Okay. So this innovation is the heart of 3D printing. Innovation of new products. So application, you can see so many areas: engine, housing, communication, satellite, electronics, space. You have turbines, aerospace component, and component of your design, and also civil engineering, electrical engineering, electronics, mechanical, all you say engineering. Then the only thing is how you program your component. What is the application like this? This is not possible printed normally. So it is possible to print this type of structure. This is a lattice structure. This is a lattice structure. Okay. So this is the heart of this thing. So how do you go about? This is fishbone diagram. This is fishbone diagram. Actually, we have taken from GE, General Electric, when they are, during 2021. So we are trying to configure the process. Earlier it was not there, and they were doing on ALSI 10mg powders. Okay. So we identify the machine, we identify the materials under the powder qualification, then powder recycling, then the process and the parts. This part is our output product and the material is our input product. Machine is also the process. So this is input, this is output, and this is the process. Machine element, and this is the printing process variables, process parameters, part orientation support, part replacement, and nesting. Okay. So since 3D printing machines are being developed by different companies and different, but there is no still standardization. So that's the thing. Then powder qualification is very important. So particle size distribution, particle morphology, and flow rate. So in this we may not select all, just like you're having expert system like ChatGPT. This also going to generate a expert system for given powders, given machine, given process, and given materials. What type of products you are going to get in AM part. Okay. So this is pre-processing, product design, you product design, machine, AM part, final product, and you go for machining. This is a traditional one, so do you do CNC machining. Okay. So in this case, you are going to have to bring machine this complex shape, and geometry. You see the geometry here. It should be either 5-axis machining or 6-axis machining, CNC machining, which is costly and also difficult to program. But that can be done simply by layer by layer. So laser additive manufacturing, powder bed fusion, direct energy deposition. So we are laser melting. We are melting. We use this one. Powder bed fusion by laser melting. We have taken this one. So this understands for understanding the process. Okay. So this machine we have used SLM. This is 200 SLM 280.0. So higher versions have come. So this is the specification, the process parameters operating on this machine, and this is the methodology of roller. It deposit material and laser scan, and this whole thing is put in a chamber, vacuum chamber pressure here, minimum size, scan rate. This it should be vacuum pressure here. Okay, and this laser melt these powders, and fuse into this component. Okay, so this way it is. As I was telling, as youth, you can build your own machines. First thing is you should understand the elements in this one. What are critical components you can purchase, but basic elements you can do on your own, like build your own machines, do it yourself type of machines. Okay, so this is the specifications we have used. Inert gas consumption 5 liters per minute, laser power 400 watts, and now if you are using titanium, you have higher power rating. Beam focus diameter 80 to 150 micrometers, feature size and build up area, laser power, build up envelope, LBH. width and height. So this is machine specific, okay? For this is machine specific, we are going to get the this thing. So when powders are picked up like this, what happened? The powders are deposited here. Then fabrication piston push the material up, and laser power melt the part of the powder. And when the powder laser beam falls, so it melted this part. Now it is this part. So this center of the beam, laser beam, but this is the diameter of the laser beam. And it melts this type of space. Melted powder also melts neighbor powders. And the whole depth will go into some depth only. So melt pool depth, right? So melt pool width, melt pool depth, melt pool width, right? And this is a layer thickness that we are going to use. Then this is now solidified powder, solidified metal. Because of vacuum pressure, vacuum inert gas. So this prevents the formation of oxides in this layer, and no slag is formed. So this is the width of this one, and here it goes on melting this process, right? So this is the schematic diagram for SLM. So this is the machine. Actually, this machine is in our college. This is funded by RUSA. RUSA 2.0, Center for Prototyping Design using Additive Manufacturing Product Design. So in your college also you have a similar setup. So you can also use your ideas, right? So then using this one, we developed these specimens as per ASTM. Conventional this specimens are printed by DOE L9. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 components are there. Design of experiment, 9 components are here. These are metal ALSI powders. So luckily powders is supplied by this SLM company only. Okay. This is a powder bed fusion. Cleaning, backspace control. This is a front end. This is the printing process. This is a printed components. This is the powders, and after finishing it's there. So what are the process parameters? Laser power, spot size, scan speed, scan spacing, scan pattern, particle size, particle shape, distribution, powder bed density, laser thickness, powder bed temperature. You can vary this temperature also, but we have not varied. We made it constant. Then powder feeder temperatures, that's also constant. So what we did is scan speed, spacing, pattern, laser power, spot size, and particle size, shape. We do this analysis here, this part. We do analysis of this part, right? So how we achieve this fusion between the powders? Okay. So already GE Electric was doing research in this area. So they have identified this triangle. This triangle
And they told if controlling scanning velocity and scanning powder, laser power, scanning velocity and laser power for a given powder density, we can obtain a defect-free component in this zone. Okay. So if you have a high laser power, you are going to get a keyhole like this, keyhole formation. If you have and high scanning velocity, you are going to get this type of lack of fusion between the powders. Okay. But you can have scan velocity and laser power optimal along this path, straight line. You can get a good density fusion of the powder fusion metal. And if you go beyond this one, high scan velocity and high power laser, so you are going to get balls like this. You are not going to get density powders. Okay. So this is the direction diagram, direction information for us to go and do some work in this area. So common defect: delamination, powder shortening, distortion, recoater blade damage, and micro defects, macro defects, micro defects, lack of fusion, keyholing, and keyholes you have, and balling. So these are micro defects and these are macro defects that will obtain by 3D printing. So you have to avoid these things first. So to avoid this one, you have to have some guidance from this zone. Okay. So we did some literature survey. Literature survey from different authors. All do not work on same purpose. They work on different purposes. So one is mechanical properties. To get better mechanical properties, same machine, what are the parameters selected by them? So this is the author. This is the purpose of study: investigating achievable accuracy and 3D printing, printed rapid prototyping journal. Actually, you write page number also. And this is the parameter setting. And this is the observation. And here also, this is rapid prototyping, Campan et al. Process optimization, microstructure analysis of SLM of ALSI 10 mg. So this is 170 watt to 200 watts is used. Scan speeds 200 to 1400 mm per second. So observation is lower scan speeds 1100 to 1200 meters per second, increase strength but decreased density. That's the observation. So like this, you need to conduct a systematic study to arrive at optimal parameters. Okay. So these are mechanical parameters, all different journals. What they did also, component. These are all 3D printed only. Then fatigue analysis. 3D printed fatigue analysis. Okay. Just like your ball bearing or your component which is subject to continuous force like your springs. Okay. 3D printed springs.
So they did SLM process itself and power, laser beam density, layer thickness, laser scan 500 mm per second, and laser spacing 0.15 mm. Observations: samples built at 300 degrees centigrade. Sample built at 30 degrees show higher fatigue strength with the orientation at 45 zero orientation than in 45 degrees and 90 degrees. Must be improved to increase current density 99%, avoid imperfection despite porosity and imperfections observed. Okay, so this is a fatigue parameter study. Then wear characterization. Wear characterization also, same metal powder is taken, same SLM machine, and same identify the parameters here. And what are the outcome of that study, journal papers. Okay, so that is noted. Then once that is printed, we have to see the topology, geometric complexity is the hallmark of 3D printing. Any shape that is in your mind, that is going to be printed. Okay, that whatever you have in your mind, okay, I want this shape. You can use B-splines, cubic splines, Bezier curves, and freeform surfaces. Freeform surface also, no problem. Any contour, any geometry, say any geometric complexity can be designed and printed with ease, which is not possible very much in the CNC machining. So that is the thing, okay? So topology optimization, also study the mathematics behind the topology. So Voronoi scheme, topology optimization. In the initial phase, you have to take a very simple problem for topology optimization. Then you can build up complexity into the topology, geometric shape. So here, suppose a double cantilever beam and hip implant is designed. So this is the double cantilever from hip, implant is designed. The support structure of after optimization can achieve weight reduction by 60%. So your hip, most of the problems which is coming here. So that is addressed by this paper Cheng et al. In the Journal of Additive Manufacturing. So this in 2000. Our work was in 2021, 2020 and 2022. So in that time we did this. So we take some inference and reference from here. Okay. So how much we studied? Literature survey, background study, dimensional accuracy, experimental. See, all are, experimental only. Nowadays you can have simulation also, but practically you are doing the experimental. Tensile strength, process optimization, thermal behavior, wear characterization, so many papers. And experimental also, topology optimization, lattice structures, these are all. If you see our background study, 3D printed component, tensile strength, dimension accuracy, process optimization, thermal behavior. So most of them are focusing on the strength. Okay. And
Second highest parameter is dimensional accuracy. In the case of 3D printed components, it should be very high. Okay, accuracy. Once process characterization done, we can focus on this dimensional accuracy and process parameters and thermal behavior. Okay, so this is the background study of this. So what literature survey, what we have done is 70% of our papers are this ALS site NMG because we have selected that powders and some are in titanium. Okay, 20%, but related to our work, and other materials are there 10%. Okay, so you see static properties testing, dynamic properties testing, and topology optimization using 3D printing. Okay, so this is how you classify your studies, background studies, especially if you are going for innovation. Okay, so this is it. Then experimental number of papers and simulation so many papers. So this also is orthogonal L-line array, Taguchi method. This is the L9 DOE, L9 orthogonal array DOE. This is the parameters. What are the parameters taken? So whatever design you are making, we want it to be accurate. Okay, 100%. This is plus and this is minus. This is old quality is this goalpost theory. Goalpost theory is lower specific limit and upper specific limit. But our target is to get the goal. Okay, so this is our target. So, and y-axis is missing. Quality loss function. This is the quality loss function is minimum. Quality loss function is minimum using Taguchi loss function. Taguchi quality loss function. So Taguchi cost loss function is when you define make a defective product, it is a loss to society. Loss to society. So that is avoided. Proper design of parameters. So this is the equation, this is a target, this is a deviation, and this is a constant, this is a loss function, right? Right. So we take some parameters, larger the better, smaller the better, nominal the best. Okay, so then we did some simulation. This is an aerospace component. We try to topology optimization, tools used, the machine testing equipment used, fatigue testing. This is the fatigue testing we used in our what you call old machine. We renovated it and repair and use it. Okay, so these are the loads used on that one. These are equipment all we have tested. Radiography test, then this density test, powder density test, then microstructure, scanning electron microscopes. So whole thing you have to write down. You are wanting to make innovation or patent or copyright, you have to write down your work chart like this. You have to write down work chart. Starting with the literature survey, objectives, problem definition, tools and technique, additive manufacturing. Objective 1, what are the tests you are going to conduct? Objective 2, which chapter? Objective 2, which chapter, process parameter, static or dynamic you have to do. Then experimental AM analysis for case study, airspace application. Then wear characterization, then optimal wear. Then AM simulation studies also you can conduct. Then conclusion, and this one. Okay. So the first part of any aim component manufacturing is first is drawing. So this is a drawing we try to print as per ASTM E2948. E2948. A little bit different from conventional method of fatty specimen design for tensile testing. Okay. So generator 3D printed, 3D print model, 3D printed, CAD model errors, correct the CAD model errors. Then we did T1, T6, T1 to T6 is there. 6 components printed. So temperature, so SLM printed the components, then scanning. So we dimensional accuracy. This 3D scanner, this is 3D scanner. Here this is a specimen put and scanner rotates and you get the total dimension of this specimen here. So 11.01, 11.11, 11.3 and 7.63, 7. So accuracy of second decimal. All specimens are tested like this. So since this is costly, so scanning was how many? 1, 2. This is the standard. This is the standard. Okay. This is what we expect. How much? This is 11, no? This is 11. This also 11. Here it is 7. Our printing design. So this is 7.63, 7.66, 7.59 is a thermal distortion is there. Because 6.03 error is there. Here 7.6. So 0.01 error. So here it is this thing. Geometric distortion of the component. Also, whatever your mind is there in a 3D printing, you see, you are not getting through scanning. So this, so let's go back. Yeah. 7 point, gauge length is 7.5. And this is 11. This is also 11. And here 7.65. Okay. So this diameter is 11. And correspondingly, we should get 3D component same. So distortion of 0.59 extra, 0.69 extra, 0.63, 0.66. So this part to this part. Okay. So whatever we are having in mind in our drawing, that we are not able to generate or print to accuracy of this one. Maybe you can take accuracy of this laser scanner, ARC 3D scanner. ARC 3D scanner, accuracy is also important. Environmental thing. So that distortion may be due to environmental effects. So this is some thermal distortion of the parts 3D printed. Okay. You see overlap and thermal distortion for 300 watts and 400 mm per second. And you can see microstructure defects. So 3D printing will not give the accuracy geometric, geometric density, size, and shape. Because process parameters are varying, and powder is also varying. So doesn't mean that if you give a 3D print, you will get an accurate part, right? So that is observed from here, from this finding. So this science scanning, that we have some porosity marks. This is full density, and this is having some porosity here like this. So this is tested on this machine, fatigue testing machine. The line diagram is this. So you hold the component here, you supply the motor torque here, and apply the load bearing. Apply load bearing here, you different loads, and how many revolutions the shaft has rotated, counter, revolution count, taking the information. Okay. So then out of 6 samples, see, you are getting 90, 108, 82, and 85. Hardness is also varying. Hardness also is varying. So it is difficult to capture the precise information of 3D printing machine. So fatigue testing. So how much time we have, sir? 14 minutes. Huh? Okay, 12:45. Right. So this is our 7.5, then specimen design. So this is experimental design. Then powders, no, they will not give you exact size. So we have to characterize this one. Particle, powder particle size. So this is various particle size. So volume, percentage, you see 10 to 100 microns. 10 to 100 microns, the peak value is 17. Approximately 17% volume. The maximum is here. Then the remaining particle size distributions. So 10 to 100 micron particle size distribution as supplied by the SLM machine, SLM Solutions Group. They have supplied these powders. So you see 20 to 63 microns. And powder weight residual is 0.694%. Surface area is, so this test, it's this density, powder density is done by Archimedes standard principle. This DMRL materials testing laboratory, they follow this Archimedes standard principle. So according to, so we have tested from them only, our sample. The distribution is like this, and this one. So you got 20 to 63 micrometers. Okay. So morphology test up to T9. Theoretical density, ASTM standard, laser speed. So we conducted this one again. So again you did laser scanning. So micrometer means you micrometer CMM machine you will not get accurate. So laser scanning component is put here. This one, and this whole table is rotated. And total data is put on this computer. Okay, this computer, and we get the dimensions like this.
different dimensions. So 9 trials are conducted. Right. So different variation of the size. Then microstructure study, we have to get a defect-free component. Defect-free component. You see a porosity, oxide formation, unmelted powders, initiating defects, here porosity, cracks. So we have to avoid this one. So this is for T1, T2, T3. Here this is T7, this is T8, and this T9. And these are the process parameters. Okay. So where does it come? So this is our scan speed, and this is our area of operation. We did this one, SI distribution. So this scan speed. So we are getting good T4, T5, T6 defect-free components. Fully dense defect-free component. So T4 to T5, T6. So here thermal distortion. Here also keyholing and porosis. So that we have identified. Okay, we have a question hour discussion. Hello. Question hour feedback is there, na? Errors or any? No information, feedback, doubts will come from the, you just check. Okay. Huh? No doubts. Okay. So this is results and discussion for hardness. This is fatigue testing and results and discussions. Results and discussions. Wear test. This is a DuCom machine. This is a screen of this one, and your wear test parameters here coming here. DuCom machine. So this is the thing. So on this one, we test all 9 samples and identify the characterization. T4, T5, T6. So this gives a proper density, but even this is unpredictable, and 2 are proper, and another one is at the bottom. So some interference, some sort of discussion is required. And radiography. Radiography also you have to tell. Radiography gives internal damage, internal full depth. So we have to non-destructive testing. So we have to see the whole volume of the printed specimen is defect free, whole volume. So the cracks are not visible, but my scholar, he identified 2 cracks here. And this information is given by the NDT inspector, indicating that. So the picture is not showing any cracks. So this interpretation by the NDT radiography inspector. So where he identifies as an expert, so he indicates the error. So what is it? Defects obtained 225 watts, 400, 225 watts, 600. Achieved for sample T5. This is T5. This is for T5. Okay. It's not moving. देखो हो गया, वही लास्ट हो गया. आ गए. So another test, parameter test, as built. We also heat treated, suitable to working conditions in the real time. One is our experimental, one is a real time working environment. So as built and heat treated. So what is the yeah, okay. Next. Then specimen testing, tensile test, preheated up to 200 degrees centigrade for 2 hours. So melting point is 350 something aluminum. But we heated up to 200 degrees and kept it in the oven for 2 hours. So it is little bit better strength. How much? 32 points, 13 to 15, it increased. Okay, next. Young's modulus as printed. Okay, next. As printed and as heated. Next, fatigue strength. Fatigue strength also, what happened? This schematic diagram, go down, next, yeah. So what we have, as printed, preheated. So both also parameter setting. So 116 as printed and 174 for heat treated. So increase in the strength. And this is 145. This is 145. We have 174 this side. As printed, in the case of heat treated, it has decreased. What is this number? 175. These 3 specimens, these 3 specimens, 116. 174, this one. So dynamic performance specific testing, these are expenses. Okay. So SN curve. Approximately we try to build. So as cast, this is from a reference paper, preheated our work, and as printed is getting better performance, and preheated to 200 degrees centigrade. This is sorry, this red one is as cast, as manufactured, whereas this green one is as printed, and this violet one is our preheated. So increase number of cycles and also load, increase number of cycles and load. So not much, but 5 to 6% like that. Okay. So this is as cast and literature survey. Okay, next is coming up. Okay, next. So there are all matrix equations. Next, go down. Next. This is a wear test. Wear test, what we need to find out. Friction ranges, minimum, maximum. Wear rate ranges from minimum to maximum. And friction ranges 0.01 to 0.121 for different materials. Okay, next. Okay, next. Yeah, next. This is fatigue testing and our characterization. Heat treatment cycle. So we did another variation, cryogenic condition. So same 3D printed component is put in
minus 80 degrees centigrade. Minus 80 degrees centigrade for 72 hours. For 72 hours. And again cycle to plus 200 degrees centigrade for 2 hours. And this 28 degrees is the room temperature, operating testing room temperature. Okay, so that is the thing. Then what is the performance here that we evaluate? Mechanical strength, microstructure, all those things. Next, wear characterization. Back, please. So this one, no, minus 80 degrees centigrade, we have taken from this reference 1110 as a comparison, right? Okay, next. Right. Next. Then topology optimization. Next. This generative testing. So back. Topology optimization, we have to first generate a geometry, characterize it, size and shape. Next, and find out the CG, then loading conditions, then loading conditions, the constraint conditions. Next, then use the generative topology. Next, next, and build an optimized part geometry like this. So which is not possible to build otherwise. Which is not possible to build using conventional machining. So this you can generate by 3D printing. So you have to define the parameters like this, lattice structure. In this case, I think square lattice structures is taken. Okay, next please. Next. It's back. So these are the publications, journal publications from our work. So six journals go down. Total 10 papers and 2 conferences. Next. 3 conferences and 1 book chapter. So this was in year not written, 2021. So by this it got published in Taylor and Francis. Okay, next. These are some references. Next. Okay, leave it. So thank you. Questions are there?
Yes, sir.
Discussion.
Raymond, question in the Google Meet.
Google Pen.
On your microphones.
Display leda questions.
All you can now you can unmute. Yeah, participants.
Message. Give him a message.
Yes,
Attendance is also.
Okay. Please, participants, if you have any questions, please drop. Please drop your questions.
Yeah. Drop it. Any doubts you can ask.
Any doubts regarding, you can interact with us like this opportunity. All participants, please. You can ask your questions. Hello? I think all are, any students here, if you have any doubts regarding printing or technologies, you can interact. Any students, please utilize this opportunity to interact with the participants. Come here, can unmute or for the questions. Now your microphone is unable. You can now share the questions or drop. You will answer the questions.
This 3D printing is not limited to one, because 3D printing will come in engaged between the price, because finally it is the work order or job requirement that is important. Or you can gift this type of objects also you can generate and sell, right?
And can we do crystallization by analytic process?
Can we?
Can we do a recrystallization by analytic process?
Recrystallization.
Yes, sir.
No, this is, you have powder and you have wire. So wire and powder is melt. You can after, that's what we have done, no? After printing, we heated up to 200 degrees centigrade. Melting point of aluminum is 600 degrees centigrade, approximately. So we try to achieve 200 degrees centigrade, 1/3 of melting point of the commercial aluminum. So that's how. You can go up to 400 also, but again it will become semi-solid, semi-liquid metal. Therefore, distortion will take place. Again, cooling to room temperature. Geometric distortion will be there. By scanning itself, we are not getting proper accuracy. That's why. So, what we designed for 7.00 mm, but we are getting variation for metals because of the heat. heat cooling, and powder. Okay, right. Thank you.
Okay, anybody who's going to ask questions from backside there, last benches? Any questions you have? Any queries? Okay.
Sir,
With this, yeah, please.
sir, which research is better for 3D printing for now, present?
Yes, please.
Which research is better for 3D printing?
Which research is better for 3D printing?
So as there are number of components, products in the market, there are plastic, non-plastic. Okay, which product we have printers for metals and non-metals, industrial plastics, thermoplastics. So those types of metals are available. What you need to know is where it is used, where nobody can manufacture and supply. For example, like Rolls-Royce or some company, Honda, they have their own proprietary components. They do not make in large numbers. So product specific and required very urgently. That time you can go for metal or not metal. Before that, you have to characterize that metal strength, properties, wear resistance, functional testing, dynamic testing. Then you can supply. So nobody will buy your product unless it is certified. And already if you are known, and you have to have GST and all those things. Right. Yes. Is your question answered? Okay.
Any question, any queries? Anybody? Okay, with this, I take a privilege to thank you, Dr. Geja Rajendra Prasad, sir. Thank you so much for your insightful presentation today. Your expertise and engaging delivery were truly appreciated. We hope to have the opportunity to collaborate with you again in next FDP. Thank you all. A huge round of applause. A huge round of applause for our guest of honor, dear Dr. Geja Rajendra Prasad Garu. With this, I also welcome our Vice Chairman, Mr. Tausif sir, for this 1 week virtual national level faculty development program. So please have a huge applause, sir. I request Vice Chairman sir to please speak for us on this occasion.
Respected Rajendra Saab, Head of the Department, faculty members, students. At the outset, I thank Rajendra Saab for accepting our invitation and coming forward to be a guest of honor and be a esteemed speaker. क्या हुआ? क्या disturbance है पीछे? What is the disturbance? What is the issue? Huh? Sir, thank you very much for accepting our kind invitation. Our people went and spoke to him and immediately he accepted and he was very kind enough. He is a governing body member. I don't know if you people know, साहब जो है हमारे governing body के member है, तो जितने भी हमारे college के जो rules है, regulations है, साहब का बहुत बड़ा involvement रहता. तो आपकी जो degree आती है, degree के लिए भी जो rules and conditions है, साहब के guidance में ही होता. आप बोले बच्चों को ये बात. साहब जो है, he is a university nominee for a governing body. So all the rules, कितने credits आए तो pass होते, कितने credits आए तो promote होते, कितने स्कोर आए तो आप पास होते, प्रमोशन क्या क्या बोलते हैं, माइनर इंजीनियरिंग के लिए, मेजर इंजीनियरिंग के लिए, सब चीजों के रूल्स में जो है साहब का कंट्रीब्यूशन है। इसके लिए आप लोग पूरे मिलके जो है साहब के लिए एक ताली मारिए। थैंक यू सो मच बोलिए। आप for your faculty recruitment, for your faculty research, for all the policies, for conduct of various events, sir's approval is there and his blessings is there for all of us. Thank you very much, sir. And with regards to this program, I think it's a very interesting program, given the outlook for mechanical engineering. Exploring such innovative avenues will always, this is what the need of the hour is. And you all should upgrade yourself, upskill yourself to make sure that you are in line to be industry relevant when you graduate. All right. Thank you very much. And thank you very much, sir, for helping us out. Thank you to IMechE also for sponsoring the event.
I request our Vice Chairman, sir, to please felicitate the guest of honor today, Geja Rajendra Prasad Garu. A huge round. I, on behalf of the committee and the department, we thank our guest of honor again, Dr. Geja Rajendra, his insightful presentation today. We hope to have the opportunity to collaborate with you again. So, dear, I hope you have an engaging first day of our FDP. Thank you all for your participation and valuable contribution. We appreciate your active engagement and look forward to successful second day tomorrow. Thank you all. Now, and express our gratitude. Thank you all the participants for attending this first faculty development program. We hope to see you tomorrow again. Thank you all.
Thank you, dear all participants, and good morning to one and all. It is indeed great honor and privilege for me to deliver the vote of thanks on this special day of 1 week virtual national level faculty development program. First and foremost, I would like to express our heartfelt gratitude to Professor Rega Rajendra Garu, sir, Dean CDC and Professor, Mechanical Department, Osmania University. His insightful talk on successful 3D printing of industrial components using the laser powder fed fusion, a case study for the strength and durability, was incredible and enlightening and provide the comprehensive understanding advanced additive manufacturing. Thank you, sir. Finally, I thanks our management and institutional leadership for their continued support and encouragement in organizing a knowledgeable sharing platform. Thank you once again. And dear participant, we have circulated the feedback form in the chat box as well as in the WhatsApp group. Kindly fill the feedback form and submit it. Thank you. To 315, na? Yeah, lab for us. CAE lab.